Good morning dear students, welcome back in a engineering chemistry class. I am Asha Pawar working as an assistant professor at SNJB's Letsav KBJ College of Engineering Chandwad Nasik. Student, in last session we learned about biodegradable polymer polyparaphenylene vinylene as electroluminescent polymer, its structure, its properties and its applications. So again I revise the properties and application. PPV, that is polyparaphenylene vinylene, is a diamagnetic material. It has a very low intrinsic electrical conductivity. It gives bright yellow fluorescence. It is generally insoluble in water. Its conductivity is low, and that's why its conductivity increase on doping process. So applications of PPV, it is in the form of thin film for a information display. It can be used automotive instrument panel backlights, backlight for a liquid crystal display. Electroluminescent night lamp can also be manufactured from the PPV. It can be used for the long life full color displays. It can be used for the flat panel displays. It can be used in the photovoltaic cell. It can be used for the decoration of theater, assembly hall, etc. That is, generally PPV is used in electronics and telecommunication industry for the various purposes. So the next specialty polymer in your syllabus, that is a conducting polymer. Student, generally we know that polymer are a bad conductor of electricity, but some polymer can also be prepared and that can be used as a conducting polymer. So organic polymer in general are a bad conductor of electricity because of non-availability of free electrons. So there are two types of conducting polymer, that is extrinsically conducting polymer and intrinsically conducting polymer. So what is extrinsically conducting polymer? An extrinsically conducting polymer material is the one which is filled with metal powder, metal filament or graphite powder to make it a conducting. Means those polymer are generally very less conductivity, but we increase the conductivity by filling that polymer with metal powder, metal filament or graphite powder. So such a polymer are nothing but what? Extrinsically conducting polymer. Then intrinsically conducting polymer. An intrinsically conducting polymer material is the one which can conduct electricity by its own. Means some polymer have the property to conduct electricity by its own due to their structural stability. For example, trans-polyacetylene, polypyrrole, polyaniline, uh, polyvinylene, etc. So what are the structural requirement for the polymer to be conductive? An organic polymer show appreciable conductivity if some structural requirement are there from them. First is the polymer chain contain conjugation, that is alternate single means sigma and pi, that is double bond. Means those polymer chain containing conjugation, alternate double bond, single bond, double bond, single bond throughout its chain, so that there are resonating or mobile electron for conduction. After the due to the conjugation, there are resonating or mobile electron for the conduction. Second property, such a polymer is highly crystalline and there is a high planarity in structure. If structure is not planar, then it not possible to conduct the electricity. And one important thing, that is polymer must be highly crystalline, not a amorphous. Third property, presence of aromatic ring in the chain with a continuous resonance enhance conductivity. Means polymer having conjugation, polymer should be crystalline, planar, But addition to that, if aromatic ring is there with a continuous resonance, then such a polymer always and always show high conductivity. Then polymer should have a linear chain. This is again most important property or structural requirement, that is polymer should be have a linear chain. So what are the example of such a polymer that containing the structural requirement? See, alternates sigma and pi bond, should be linear, should be planar and highly crystalline, and each and every polymer structure drawn here, that is for the trans polyacetylene, polyparaphenylene, polypyrrole and polyaniline, all the structural requirement to be fulfilled, that is conjugation, linear, highly crystalline, planar, and those containing aromatic ring show always high conductivity. Then what are the applications of such a conducting polymer? That conducting polymer generally used in the electronic field, that is for the making of rechargeable lights, in electronic devices, in a optical display, in solar cell, in telecommunication system, for making of switches. It is used in electronic devices such as transistor, photodiodes and light emitting diodes, etc. So most of the conducting polymer having low conductivity, that is they are generally nothing but the low conductivity. The conductivity of such a conducting polymer can be enhanced by using doping process. So there are two types of doping used, that is p doping and n doping. That is p doping means oxidation, removal of electron takes place and positive charge is developed on the polymer chain, then increase the conductivity, and the various Lewis acids like I2, bromine, FeCl3, PF6 used as a p dopant. And the second type of doping is a n doping, that is it is use Lewis bases like lithium, sodium metal, etc. And there is a creation of negative charge, that is due to the addition of electron, negative charge is developed on a polymer chain, increase the conductivity. Means to increase or to enhance the conductivity, doping processes can be used, that is p doping and n doping. And this doping can be used generally for the ICP, that is intrinsically conducting polymer, that shows the conductivity due to its structural feature. And see student, these are the polymer that having some structural features, and to enhance the conductivity of this polymer we use either p doping or either n doping by using Lewis acid and Lewis bases respectively. And for increase the conductivity of extrinsically conducting polymer, we use the metal fiber, metal wire or graphite powder or carbon black, etc. So thank you.